Assalamualaikum and hi. Today, my Group 2, will present about a project that is water delivery system to a bungalow house. So this is the list of our teammate. We have Muhammad ADLAN, we have Nur Kamila, and me myself, Umar IRFAN. So for introduction, this project is done at an area that has a water pond which is 1 mile far from here, and we are required to supply water to the bungalow that is built at the top of the hill which is 150 meters high. The water is used for daily uses such as cleaning, cooking, drinking, washing, and bathing. For the bungalow's resident, which is up to 50 people, water plays a very significant role in daily life of each resident. This project will show the pipeline design, type of material that are being used, and the total cost of material. The pipeline are designed to supply water to all rooms that use water such as toilets, kitchens, and bathroom. Water source that we use is from the pond near the bungalow. To deliver the water to the bungalow, a pump is used to siphon water from the pond. The water is then distributed to all the facilities in the bungalow by gravity drainage. Our group has chosen to design a pipeline system from a rust resistant, strong, durable, and at reasonable cost.
So, for the problem statement for this project is to create a dependable water delivery system from a clear water point to a bungalow 150 meter above, meeting peak demand for up to 50 people. Design factor include distance, elevation, water demand, efficiency, sustainability, safety, and maintenance. Focus on reducing water loss, optimizing energy use, and incorporating eco-friendly practice for a sustainable water supply.
Assalamualaikum, my name is KARMILA and I will be explain about objective for this project. The project aims to improve student understanding of the lecture syllabus covering pump types, pump varieties and length. It involves calculation for pump power, pipe diameter and length, emphasizing minimizing losses for uninterrupted water distribution in a bungalow. The project requires estimating resources for the proposed pipeline system, promoting communication, teamwork, and logical thinking skill among students.
So now I will talk about the scope. The scope for this project is the project aims to establish a reliable water delivery system for a bungalow in Sungai Penchala, Kuala Lumpur. It involves planning, design, procurement, installation, and commissioning to ensure a consistent water supply.
Now I will be explain about the main component of water delivery system. The function of mixing chamber is induced turbulent mixing for even distribution of chemical coagulants in untreated water, triggering coagulation. These agents prompt small particles to clamp together, facilitating their removal in the treatment process via settling, scraping, draining, or filtering. Function of flocculators is coagulated water moved through flocculation basins where mechanical pedals gently mix it. During flocculation, small coagulated particles are added, causing water particles to adhere, forming larger settlable particles. This can be efficiently removed through sedimentation and filtration. Function of settler sedimentation tank is to reduce treated water velocity below the threshold to prevent transporting settler particles, enabling pressure to guide 90% of settlable solid to the basin bottom. This aids in relieving filter workload by eliminating suspended solid denser or heavier than water. Function of filter tank is water treatment facilities use multimedia gravity filters with layers of iron oxide, filter sand and garnet. An under drain system collect filter water as gravity guides chlorinated water through the layers, acting as an effective strainer to capture particles. The filter tank is vital for removing contaminants left over from the sedimentation process. Function of water storage tank is used to keep treated, untreated water in storage. What function of water pump is transferring water from the river to the pond and then pumping water from the pond to the water system of the bungalow. Function of PVC pipe is to examine for any leaks that could cause pipe pollution at high temperature. And lastly, function of block valve is to regulate the flow of the fluid.
So this is our schematic diagram for the project. So as you can see here, we are using globe valve, some pipes here, and some pumps to take the water from the pond and deliver it to the bungalow.
So this is the calculation for this project. The average person use water per person in Malaysia is 245 liter per day, where and the maximum capacity for the bungalow is 50%, and we can multiply it by 50, and we will get 1.418 times 10 to the power of negative 4 meter cube per second. So this is the volumetric flow rate. Next, we need to calculate the area of pipe. So for this project, we use two different diameter of pipe, where the big pipe is 0.04 meter for the diameter, and the small pipe where the diameter is 0.032 meter. Hence, we can calculate the area for both pipe, and will get 1.257 times 10 to the power of negative 3 meter square, and the small pipe will get 8.0425 times 10 to the power of negative 3 meter square. After we get the area, we can calculate the velocity in pipe for both pipe by using the formula Q equal to AV, where V equal to Q over A. So by using this formula, we get for the big pipe 0.1128 meter per second, and the small pipe is 0.1763 meter per second. Next, we can calculate the Reynolds number. The average temperature of the water pond is about 30 degrees Celsius, and after referring to the table of the physical property of water, we can get the kinematic viscosity at 30 degrees Celsius, which is 8.009 times 10 to the power of negative 7 meter square per second. Next, we can calculate the Reynolds number by using the formula rho Vd divided by mu and Vd divided by nu, and we will get 5663.66, which is greater than 4000. Hence, this is the turbulent flow, and the small part we will get the Reynolds number, which is 7044.075, which is greater than 4000, which hence this is also the turbulent flow. So for the pipe, for this project, we use the PVC pipe. So the absolute roughness of this pipe is 0.0015 times 10 to the power of negative 3 meter. Next, we can calculate the relative roughness for each pipe by using the formula epsilon divided by d, and we will get 3.75 times 10 to the power of negative 5, and the small pipe we get 4.6875 times 10 to the power of negative 5. Since this is the turbulent flow, the value of friction factor F can be obtained by using the following equation, Barr's equation. For the big pipe, we get the friction factor is 0.003624, and the small pipe we get 0.034. From the value of F, we can calculate the major and minor losses. For the big pipe, the length of the pipe is about 1761.1344 meter, and the velocity is about 0.1128 meter per second, and the friction factor is 0.036244, and the diameter of the pipe is 0.04. The major losses, we can calculate the major losses by using the formula F LV squared over D2G, and we get 1.035 meter. Next, the minor losses, we need to calculate all the KL value for reentrant, long radius 90 degree flange, and globe valve fully open. The formula for the formula to calculate the minor losses is KL V square over 2G, and we get 7.393 times 10 to the power of negative 3 meter. Next, we need to calculate the major and minor losses for small pipe. The length of small pipe is about 10 meter, and the velocity is 0.1763 meter per second. The friction factor is 0.034, and the diameter of pipe is 0.032 meter. And the major losses we get 0.01683 meter, and the minor losses we get 1 point, and the minor losses we get 2.539 times 10 to the power of negative 3 meter. Next, we need to sum all of the minor and major losses, and we get 1.061726 meter. Next, we can calculate the heat pump for water delivery system by using Bernoulli equation, where P1 is at the water point and P2 at house tank. The Bernoulli equation is given by P1 over gamma plus V1 square over 2G plus Z1 plus HP minus HL minus HT equal to P2 over gamma plus V2 square over 2G plus Z2. Based on the referring point, we simplify that P1 equal to P2 equal to 0 because of the atmosphere pressure. V1 equal to V2 equal to 0 because huge reservoir. HT equal to 0 because no energy removed by mechanical device such as turbine. And Z1 equal to 0 because of datum. Then HP equal to HL plus Z2, and we get 157.06 meter. Then we calculate the power output, where the formula is rho G HP Q, and we get 217 plus 477 watt, and P input without head loss, and we get 216 watt. And we calculate the efficiency uh, by using the formula P input over P output times 100%, and we get 99.32%. Then we calculate the NPSH to identify where the cavitation occur or not. The NPSHR given by the manufacturer is 8 meter, and we get the NPSHA is about 11.94 meter, and NPSHA is greater than NPSHR, hence cavitation will not occur.
Now, I will be explain about the pre-selection of material and types of equipment. We use 3,200 liter round water tank and vortex submersible pump. Cast iron vortex submersible pumps are durable and reliable, making them well suited for permanent installation. They are capable of handling tough conditions and can manage suspended particles without sustaining damage. The vortex impeller design provides protection against water levels, and automatic offload switch offer automatic protection. PVC offers a variety of advantages, including pressure resistance, long-term durability, excellent resistance towards the growth of bacteria, and many more. This table shows PVC piping sizing charts for Schedule 40. The filtration system effectively eliminates chlorine and impurities from water, resulting in clean and pleasant water for the entire household. This is achieved through the incorporation of activated carbon and quartz media, effectively eliminating both the taste and smell of chlorine. The water will be redirected using a 90-degree elbow pipe controlled by a globe valve specifically for the bungalow.
So now I will present about the cost analysis. So total cost for this project is 16,553 ringgit and 35 cent. So this cost is for the pipeline, water tank, submersible tank, filtration system, and globe valve.
In conclusion, the project completed on schedule, strengthened team bonds, fostering mutual respect for strengths and weaknesses. Equipment included a 3,200-litre water tank, Pedrolo VXC Vortex submersible pump, and secure PVC pipelines. Water from a pond underwent filtration directed through a 90-degree elbow pipe with a globe valve to minimize head losses. Calculation and costing phases applied fluid mechanics to the real-life scenarios. Thanks to Dr. Izzuddin bin Supi for valuable guidance and knowledge.
I think that's all from our group. Thank you.